Example number 3. Examining the relationship between the converse and an inverse of a conditional statement. Arizona is studying the color wheel in art class. Woohoo! She observes the following. If a color is red, that's our hypothesis, yellow, or blue, then it is a primary color. And if you want to see a really pretty diagram with a lot of different colors, go to page 212 in your textbook. It's very lovely. So write the converse of the statement, write the inverse of the statement, verify that the converse and the inverse are both true. So does that mean that Arizona's statement is biconditional? Explain. So A, let's remind ourselves from last class what a converse statement is. It's Q implies P. So this right here is our P, that's our hypothesis, our conclusion is the second one. So if we would write the converse, we would say, if a color is primary, then it is red, yellow, or blue. B. Write the inverse. So you can see how all of these things feel like they're kind of running together. Remember, it is the not Q. Oh, sorry, that's contrapositive. Not P implies not Q. So we would take our hypothesis. If a color is not red, yellow, or blue, then it is not a primary color. So let's go and verify that the converse and the inverse statements are true. So Q implying P, if a color is primary, then it is red, yellow, or blue. Yep, that's true. What about the inverse? If a color is not red, yellow, or blue, so say it's like purple or orange or green, then it's not a primary color. Yep, that's true. So we know that the inverse is true. D. Is Arizona's statement biconditional? Well, we know that the conditional statement, the original conditional statement, is true. And we know that so this is the original conditional. And we know that the inverse, Q implies P, is true. And remember, this is our inverse. Oh, sorry, no, this is our converse. See how easy it is? This is our converse. So since both P implies Q and Q implies P, we have a biconditional statement. P implies Q and Q implies P. Now, we know that it's biconditional because the conditional and it's no, sorry, that there should be no apostrophe there. And its converse are both true. Has nothing to do with the inverse, because the inverse is just the contrapositive of the converse. Did that just make your mind explode? So remember, only if the conditional statement and its converse are true, that's when we know it's biconditional. And those are the only circumstances under which, because we know that the contrapositive is related to the conditional statement. The contrapositive will always be true. And we know that the inverse is just the contrapositive of the converse. And so if the converse is true, and the inverse must be true, because these two are just contrapositives of each other. Well, this is just the contrapositive of this guy.